written form. It's commonly known as fine-tuning. If you have an interest in physics or science, or have taken a course in physics, you probably know about these things called universal physical constants. Some are like G, right? It's like 6.67 times 10 to the negative 11. There's the Coulomb constant. There's the Planck constant. There's a bunch of different values that we just measure by conducting experiments. But these experiments simply tell us what that value is. They don't tell us why it's that value in the first place. And the important thing about these values is the fact that if they were different, then life couldn't exist. And I don't mean life as we know it. I don't mean like we might have aliens instead. I mean like no conceivable life forms of any kind could exist. For example, if the expansion of the universe were 1 in 100,000 million billion times less, then the universe would have collapsed into a giant fireball and no life could exist. If it were a tiny, tiny little bit weaker instead of stronger, or sorry, expanded faster instead of slower, then it would have expanded too fast and stars couldn't form, planets couldn't form, life couldn't exist on planets, and, well, or in outer space because you need, certain things for any conceivable life form. And another example would be gravity, weak force. If it were 1 in a googol, which is 10 to the 100, if it were 1 in a googol different, like greater or weaker, then matter would have collapsed into black holes or expanded too quickly to even form, to be capable of providing life. And if you combine a bunch of these together, then you get a result like the probability, or not probability, but yeah, the odds of all the constants being, because there's something like 50 of these that all have to be right. The odds of them all falling into this tiny little gap that allows life to exist is like 1 out of 10 to the 10 to the 23. It's so small that it's not even conceivable by the human mind for something that small. It's basically zero. We can't even comprehend a number that small. That's how unlikely all the constants falling in the exact right place for any sort of life form to exist are. Now, the counterarguments for this. There's one major one, and that's the multiverse, multiple universes, many worlds theory. Now, I find this one sort of amusing because the main criticism atheists or agnostics have about God is that it's untestable, unfalsifiable, and there's no evidence. And then they provide the multiverse theory, which is also untestable, unfalsifiable, and there's no evidence for. But that's not the point. The problem with the multiple universes theory is, again, like all you're really doing is postponing the problem. Because one of these theories, called M theory, type of string theory, it's sort of a theory of everything that posits the idea of multiple universes, is really just moving the problem into the multiverse, because the multiverse, that mechanism, is also bound by laws such as producing galaxies. And again, you just have the same question on the same sort of idea. M theory requires 11 dimensions. Well, that's arbitrary, and again, you have the same problem as why G is this value? Why are there exactly 11 dimensions? You've only postponed the problem. But another sort of weirder counterargument to this multiverse theory is that, okay, so if there are an infinite number of alternate universes, then even though this is so small, if it happens an infinite number of times, it's going to happen an infinite number of times. So what you can actually do is you can calculate, say, the probability of 1 trillion random particles coming together and just forming, say, a horse, okay? That's so statistically unlikely, right? Just to have all these random particles from the universe just come together and form a horse. Yet, it is billion and billion more times probable than the constants falling in the right place. So what you can actually do is, if you had sort of a set of all these infinite universes, right? And say, well, how about 1%, I'm being generous, 1% are capable of producing life. Yet, let's say 50%, because the odds of all these random particles coming together to form a horse are so much more likely than a life-permitting universe. Let's say half of them have this property, that in these universes, particles just come together and form random objects out of thin air. Since the probability of life existing in a universe is independent of this property of particles coming together randomly, you would actually, in 50% of these life-permitting universes, see this happen. You would see just horses appear out of thin air. I know it sounds ridiculous, but if you calculate the probabilities of random objects forming is billions of times more likely than a life-permitting universe. So in every billion life-permitting universes, you would have a billion minus 1 on average of these random occurrences happening. It sounds ridiculous, but that's what probabilities dictate. Now, how much time do I have? Like
2 more minutes if you need it.
2 more minutes?
I'll wrap it up soon.
Okay. Well, I think I'll wrap it up there, actually. So I've covered two main concepts: first cause, fine-tuning, some counterarguments, and some reverse counterarguments. I know the last one sounded kind of funny, but if you want to talk about it later, I'd be happy to. And if you had any other questions, I'd be happy to address those as well. I hope this has at least gotten you a little more interested, if not convinced you. I mean, I'm not exactly trying to do that. I'm just trying to get people interested in this sort of thing. So I hope you enjoyed the presentation.